and you'll get a copy of this file later.
Mm-hmm.
And all of that, incidentally, is specific to my website. This is not the way we would be doing it if we were doing it through Wyzant. So it's definitely a different service.
Okay.
Okay? All right. Let's get back to the kind of things we were doing yesterday, just so I can get an idea of what we need to work on for you.
Mm-hmm.
I'm going to just check a couple of things here as to which problem maybe we want to work on. We talked about fractions yesterday.
Yeah.
Let's see here. I don't want to give you problems that are calculator problems because you don't need to know how to do those. All right, let's talk about this. Problems like this. How many odd integers are between these two numbers? So, what's the first one?
11.
Okay, what is this equal to?
It's
In other words, if you turn this into a proper fraction, what would it be?
I don't know.
3 1/3. In other words, if you divide 3 into 10, you get the whole number 3, and there's a remainder of 1, and that's equal to the 1/3. Okay? What's this number equal to? Do the same process.
Just divide, right?
Yeah, divide 3 into 62. And you can use your calculator. What you should have in front of you probably is a very simple calculator that you're just going to do addition and subtraction on. And you might as well always have it in front of you when we do a session because you want to get in the frame of mind that you're going to be in when you take the test.
Okay.
Okay? So you can go ahead and use a calculator on that even.
It's going to be 20.66.
Okay, that's okay. It's 20 2/3, but 20.66 works for this particular problem.
Okay.
Now, when they say how many odd integers, integers are whole numbers. You know what odd numbers are. What's the first one that is between these two?
5.
That's it, right?
Right.
1, 2, 3, 4, 5, 6, 7, 8. There are 8 odd integers between those two fractions.
So we have first to divide it, then we find the odd number.
Yeah, pretty much, unless you convert that to a number that you can put on the number scale.
Yeah.
It's going to be hard to make progress. So the first thing is to put it into what's called a proper fraction. And this didn't matter whether I wrote it as 20.66 or 20 2/3.
Okay.
I was going to get the same answer regardless.
Okay.
All right. What is the greatest integer that will divide evenly into these two numbers, 36 and 54? So we're basically looking for a greatest common factor. In fact, let's put a plus sign between those, and let's factor out the greatest common factor.
And how we do that?
Well, it's kind of a trial and error method. Let's see. Finding the greatest common factor. Clearly, it's not 36. In other words, 36 would divide into 36, but it would not divide evenly into 54. Okay, so what I would do is next try half of 36. In other words, we have to have a number that divides into 36 and also 54. So on your calculator, you could divide 36 by 2, and is 18. Does that work?
Right.
That's it. So this expression would be that. In other words, 18 is the greatest number that divides into both of these. Now, I immediately can tell that there's no greater number because the only numbers that divide into 36 are going to be 18, 9, 4, smaller numbers. If I were to look for a number larger than 18, well, clearly the only thing that divides into that is 36, and we've already discovered that that doesn't divide into that. So I know this has to be the largest one.
So if the first thing that I have to do is divide it by 2, right? And the number that I get is the largest number.
Not necessarily. Let's take these two numbers. What's the greatest common factor? I prefer to use the word greatest common factor because I think that's what you'll run into on the test. In other words, what's the greatest common factor between those two numbers?
Is it 13?
No, it's 27. In other words, 27 divides into that 1 time, and it divides into that 3 times. So the first thing to try is always try dividing the bigger number by the smaller number.
Okay.
And that might work, but let's change this again to be 54. And now if I ask the same, not 54, excuse me, I meant 45. Okay. Now, if we're trying to find the greatest common factor between those two numbers, 27 does not divide into 45 evenly.
Yeah.
And I can't cut it in half, but I can cut it in thirds. In other words, the next number that's going to divide into 27 is going to be 9. And 9 divides evenly into 45. So 9 would be the greatest common factor. And that would leave 3 plus 5. Okay? So it's not always cutting it in half. Sometimes it's cutting it in a third, if that's the best you can do. In other words, with the number 27, I've got to cut it in a third since I can't cut it in a half. And then I got to see whether that divides into that.
Yeah.
Okay. Yeah. Go on. I don't want to confuse you with this. It's not worth confusion. Looking for... All right. I don't want to give you just straight calculator problems. Okay, here's a good one. If the sum of 3 different prime numbers, you familiar with prime numbers?
Yeah. Concept?
Okay. If I have 3 different prime numbers, and their sum is an even number, what is the smallest of the 3? And this is a multiple choice. First of all, let's talk about adding odd and adding even numbers. Okay? Let's review the principle. If I add an even number to an even number, I get an even number.
Yeah.
If I add an even to an odd, I get odd.
Odd.
But if I add an odd plus an odd,
Even.
I get even. Okay? Those are the only three rules you need for this particular problem. Now they're telling us that it's three different prime numbers. What do two of those prime numbers have to be?
To get an even number,
No, all prime numbers are odd except which one? In other words, if I list prime numbers, notice that everything after 2 is odd.
Yeah, except 2.
Yeah, and it's that way because if any of these numbers can be divided by 2, then they wouldn't be prime.
Yeah.
Okay? So the key here is that 2 out of the 3 prime numbers have to be odd, right? Since they're 3 different prime numbers.
Yeah.
Okay, so if I add those 2 odd prime numbers, I get an even, right?
Yeah.
And it says that when you add the third prime number, the answer is even. Well, what does the third prime number have to be? It would have to be 2.
No. Okay.
Okay, because if it was anything other than 2, when I added it, I would have an odd number.
Yeah.
In other words, it's very difficult to add 3 prime numbers and get an even number. The only way you can do it is if one of them is 2.
And the other 2 is odd numbers.
Exactly. I know for sure the other 2 are odd because there is only one even prime number.
Yeah.
Every other prime number is odd.
Uh-huh.
So when I add 3 prime, if I add 3 prime numbers that none of them are 2, I'm always going to get an odd answer. That's 8 plus 7, 15. If I add those 3, that's 12 plus 11, 23. In other words, I'm always going to get odd unless one of them is 2.
Yes.
And therefore, the answer, what is the smallest of the prime numbers? That's the answer. This was multiple choice.
Okay.
Okay. Okay, let's remember what we're talking about here is kind of number theory, and that might be something that you're not that familiar with. A, B, and C are consecutive. A is less than B, which is less than C. If A squared is equal to C, which of the following could be a value of A? Could A be minus 1? True or false?
Yes.
Yeah, because B could be 0 and C could be 1.
Yeah.
In which case, minus 1 squared would be equal to 1.
Yes.
So it could be minus 1. Could it be 0?
Yes.
How?
Because A might be minus 2. No. Right. No, it's not.
Okay.
It's not.
In other words, these have to be consecutive. So if A was 0, it would have to be 1, 2, like that.
Right.
And then A squared would not be equal to C.
Yeah.
Okay, so it cannot be 0.
Yeah.
Could it be 2?
2, 2, 3, 4. No.
Well, that would mean the 3 numbers would have to be 2, 3, 4. And remember, our requirement was that A squared equals C.
Yeah, so it's right. It can be 2.
Can be 2. Okay. Let's go forward. I'm going to list all of their answers here. If n is odd, which of these could be even? Or which of these must be even?
N is odd.
5 choices. Yeah, that's 1, 2, 3, 4, 5. And the thing is, if n is odd, which of these has to be even?
Okay, so let's say that we use number 3.
Okay.
So 3, if we're going to try the first one, 3 minus 1 divided by 2, it's going to be 2.5.
Hold it. 3 minus 1 is 2.
Divided by 2
is 1.
1, yeah. So this is odd number.
Right. Make sure you do this on your calculator correctly. I think what you did was 3 minus 1/2.
Yeah, I think so. Yeah, right.
Okay, you got to be careful not to do that. In other words, do it in 2 steps if you need to, or use parentheses. In fact, I have a calculator that's a virtual calculator here. Let me pull it up here, and this will help us with this problem. In other words, here's how I would want to put it in. 3 minus 1 end paren divided by 2, like that.
Okay,
and that gives you the answer. Had I done 3 minus 1 divided by 2, that's going to give you that first answer you got.
Yeah, that's what I did, yeah.
Okay, so make sure you use the parentheses properly.
Okay.
Okay, so that's not it, because 1 is not even. In other words, which must be even. It's not which must, meaning it always has to be even.
The second one is going to be even.
Well, using the same 3 number, or using the same number, it's even.
Yeah.
But now pick another number. Pick 5.
Okay. So 5 plus 1.
You really kind of want to be able to do these in your head. You don't want to have to use the calculator.
Okay. It's going to be 3.
Okay.
6
So,
divided by...
right. In other words, so it worked when n was 3, but it didn't work when n was 5.
Yeah.
So therefore, it doesn't have to be even. We have to find one that's going to be even regardless of what n we use.
Oh, okay.
Okay. Let's check the next easiest one. Since both of these involve squaring, let's check this one. Pick a couple of odd numbers for that one and see what you get.
Okay. Mm. 2, 5, 10, 5.
Generally, if you pick 2 numbers and it works, I would go with it.
Okay.
In other words, if you pick 3, then that's 8. If you pick 5, then that's 12. Both of those are even.
Yeah.
Now let's look. So this looks like it might be the answer. Now let's examine it a little bit. If I take an odd number and multiply it by 2, does it have to be odd or even?
It's going to be even.
Correct. In other words, whenever you take an even number times an odd number, it's always even.
Okay.
And you're going to have to distinguish between adding and multiplying. Because when you add, it's even plus odd is odd. But when you multiply, even times odd is even. So this number is always even, no matter what the odd number that n is. This number right here is always even.
Yeah.
And since we're adding an even number to it,
It's going to be even.
this has to be even, no matter what odd number you have. So that's our answer, and that's all the further we would go. You certainly would not check these, and you wouldn't check those. It would just be wasted time. Okay? One of the keys of the GRE test is to make sure you use your time efficiently.
Yeah.
So once you've come up with an answer, you're done. In other words, don't spend your time disproving the others.
Right.
All right. Some of these can be a little strange, I'm sure. I want to get by this section into algebra as quickly as possible, but we can't ignore this section because they expect you to know this stuff on the test also. Okay, if I take the following three numbers, 6, 8, 10, what is the smallest integer greater than 1 that leaves a remainder of 1 when divided by any of these three numbers? And here's your 5 choices. Okay, they want the smallest one. So where are we going to start? Are we going to start at 481?
No.
No, because even if that worked, we'd still have to try 241 and 121 and 41 and 21. Right. So let's start with the smallest one and see if this one works. So when I divide 21 by 6, do I get a remainder of 1?
It's 3.5.
Okay. Illustrating a problem with using the calculator. Here's what I want to do. I want to divide 6 into 21. Goes 3 times. 3 times 6 is 18. The remainder is 3. Okay. So the fact that you got 3.5 is the correct answer, but it doesn't really tell you what the remainder is.
Yeah.
In other words, in order to get the remainder, you almost have to do it that exact method by long division.
Okay.
Okay. Let's do long division. In other words, the remainder is 3, so that's not the answer. Okay. I've got to keep going until I find a number that when I divide it by all 3 of these, I get a remainder of 1 each time.
Okay.
Okay, so let's try 41. What's 41 divided by 6? Now, do you have to use a calculator to do that, or can you do that manually?
I think I have to use a calculator. Can you do this one also so I can like...
Yeah, sure. Long division is I can't divide 6 into 4. And 6 goes into 41, not quite 7, but I can do it 6 times. And then I multiply 6 times 6 to get 36. Remainder is 5.
But why did we multiply 6 by 6?
That's just the way you do long division.
Oh, okay.
Okay? I'll do long division on all 3 of these, and you'll get the hang of what long division is. But what it means is that 41 isn't the right answer either.
Yeah.
Because when I divided 6 into 41, I got a remainder of 5.
Yeah.
I'm looking for a remainder of 1. Okay?
Yeah.
And so far, I haven't even tried 8 and 10. I haven't needed to. In other words, 6 hasn't worked in each case. But now where things are about to change. Now, when I do long division on 6 into 121, your calculator is going to give you an answer like 2.166. Okay? That's not going to be helpful. That doesn't tell us what the remainder is.
Yeah.
So, no, I doubt that the calculator you're going to be able to use allows you to convert between fractions and decimals.
Yeah.
Which means this is the only way you're going to be able to do it. You've got to learn long division.
Okay.
Okay? Now, if I divide 6, it won't go into 1. So, will it go into 12?
Mm-hmm.
How many times?
2.
Now multiply 2 times 6 to write 12.
Yeah.
Subtract those. Bring down the 1. There's the remainder of 1.
Okay.
Okay? In other words, the answer would be, oh, excuse me, it's obviously 20. 6 goes into 121 times 20 times with a remainder of 1.
Why it's 20? Why it's not 2? Because 6 multiplied by 2 is 12. Why we ask?
Right. But we're
1?
dividing into 121.
Okay.
So if you multiply 6 times 20, you get 120
Ah, okay.
plus 1 more.
Uh-huh.
Well, the real answer is 20 1/6. So if your calculator could give you the answer in fractions, that'd be the way to go, because we're looking for a 1 right there. Okay? So this number was divisible by 6 and did give us a remainder of 1. So now let's divide it by 8 and see what we get.
Yes.
Okay? Again, 8 does go into 12 one time. Not twice, but just once. Multiply 1 times 8.
8.
Subtract it. Bring down the 1. Divide 8 into 41. How many times does it go?
1. 2. No.
About 5.
5. Yeah. 5.
Because 5 times 8 is 40. It doesn't quite go 6.
Yeah.
But it goes 5. And now I multiply 5 times 8 to get 40. Subtract. There's my remainder.
Okay.
So it works.
This is going to be longer.
It works for 8. Right. It's a little harder manual division, but you're not going to have to do this that many times. In other words, you have to know how to do long division, but you don't have to know how to do it. It's not something you're going to have to do a bunch. Okay? How many times does 10 go into 12? The most amount of times. In other words, does it go into 12 twice? No, it only goes once.
Yeah.
Okay, 1 times 10 goes there. Subtract, you get 2. Bring down the 1. Divide 10 into 21. That goes 2. Multiply the 2 times the 10. You get 20. Bring down, subtract. There's your remainder.
Okay.
So we found our answer.
Yeah.
121 is the smallest of these 5 numbers that is divisible by each of these 3 numbers and leaves a remainder of 1 each time. Okay?
Yeah.
Wouldn't surprise me if maybe you learned synthetic division at some point. Do those words sound familiar?
No.
No? Okay. Well, I don't think there's any way we're going to get around long division. Let's do some long division problems. How do I divide that? Start by dividing this number into that number. Will it go?
1.
Okay. Now multiply that times 4 and write it below that. And now subtract. And then bring down the next digit.
Yes.
Now 4 goes into 32 how many times?
Um, 7.
Use your
8.
8. Use your calculator here.
Okay.
In other words, if you use your calculator and you divide 32 by 4 and you get a whole number, that's the answer.
Yeah.
If you get a partial number, it's the number less than that.
Yeah.
In other words, if I was dividing 4 into 31, I would have got my calculator would have given me an answer of 7 plus 7 dot something, which means 7 is what I would have written up here.
Okay.
You always put in the largest integer you can put. Okay, now 8 times 4 is 32. Subtract that, I have no remainder. But I still have this 0 here, so I have to add a 0 there. But it goes in evenly. There is no remainder. And I can prove it by multiplying that times that, and I will get 720. All right, let's move on.
I have to practice that like a lot.
Yeah, you need to know how to do that, but not a lot. And you could almost take the whole test and not run into the need to do that.
Oh, okay.
I'm going through sample problems here, and they're liable to give you any kind of thing. But all right, if the product of two integers is odd, which of the following must be true? Well, let's review. Even times even is what?
Even.
And remember, this is different than adding. Before we were adding, so even times odd is what?
Is odd.
Pick two numbers and try it.
Oh, no, it's even.
Okay.
It's even. No.
That's always the way to answer these, incidentally.
Right.
If you don't know the answer, just pick some numbers.
Yeah.
Odd times odd.
Odd.
Notice that's the only one of the three you get an odd number.
Yeah.
Okay. So if the product of two integers is odd, what must be true? And then I'm going to read you the answers. The sum of the two integers is an odd number.
No.
The difference between the two integers is an odd number.
What does that mean, the difference between two?
Subtract. Subtract.
Oh, no, it's even number.
Correct. The square of either integer is an odd number.
Which means?
The square means take a number and square it. Raise it to the 2 power.
No, it's even number.
Correct. So, no. Take an odd number like 3.
Okay.
Square it. What do you get?
6.
9.
9. It's going to be even number.
Right. In other words, whenever I take an odd number and square it, I'm multiplying it by itself. In other words, 3 squared equals 3 times 3. 5 squared equals 5 times 5. Well, we already know that produces an odd number and that produces an odd number.
Yeah.
So whenever I square an odd number, I'm going to get an odd number.
Yeah.
So the square of either integer is an odd number has to be true. Because when I square either one of these, I'm multiplying it by itself. When I multiply an odd number times an odd number, I get an odd number.
Right. Right.
Let's talk about factoring numbers. If I want to find all of the prime factors of a number, like 130, in other words, the following question deals with this. how many positive integers divide into 130 evenly?
Mm-hmm.
Is it 1? Is it 2? Is it 3? Is it 4? Well, the only way to answer that question is to fully factor this number. Okay? The first thing you do when you factor a number is split it in half. You with me?
Yes.
Because that's prime, I don't go any further on that branch. This is not prime. I can divide that into 5 times 13.
Okay.
That's prime, and that's prime. What that tells me is that those are the only three numbers that divide evenly into that. Well, those are the only three prime numbers. But obviously, 2 times 13 would be 26, and it would also divide into that. So 26. You know what? Let me do this a different way. This is the way they teach you in school, but I don't like this way. There's an easier way to do this.
Okay.
We'll start with 130. Let's find factors of 130, starting there. Okay?
Okay.
Next step I do in fully factoring 130 is to cut that in half, just like I did before. And then cut it in half again. Well, I can't cut it in half again. In other words, once I cut this side in half, I have to double the other side. Okay? Well, I can't cut it in half. I can't cut it in a third, but I can cut it in a fifth. If I cut 65 in a fifth, I get 13. I have to multiply this by 5. I get 10. Now, I can't really go down anymore because I can't divide 13 by anything, but I could double it. And I could double that and cut that in half. Okay?
Mm-hmm.
And now it looks like I have found all factors of 130. In other words, it doesn't do any good to cut this in half again and double this. I get the same two factors. I can't. No, I can't do anything else. I could cut that by 2 and double that, but that gives me that. I can't cut this by a third or a fifth or a seventh or anything else. So this gives me all my factors. In other words, those are the factors of 130.
Okay.
Okay?
Yeah.
All right. Let's go on. You hear that hissing in the background?
Yeah. Yeah. I'm hearing something like it's.
Yeah. I'm not sure what's causing that. That's kind of unusual, but hopefully it won't bother us too much. Okay, what we have here is a repeating decimal.
Okay.
Okay, you're familiar with these?
No.
In other words, it repeats
Itself. Okay. Yeah.
every 1, 2, 3, 4, 5, 6 digits. It repeats.
Yeah.
Okay. What's the 44th digit after the decimal place going to be?
Okay.
First of all, divide 44 by 6. because you know that there's 6 spots for each repetition.
Okay.
What do you get?
7.33.
Again, you're going to have to do this by long division.
Okay.
And I'll show you why. 7 goes into 44. How many times? Your calculator gave you the whole number.
7.33. 6. Oh, yeah.
6 point something. But we need the remainder. Okay.
Yeah.
So your calculator is helpful in that it identifies the first digit.
Yeah.
But now we need the second digit. So how do we get it again? Do you remember?
Yeah, we multiply 6 by 7, which is 42. And we get 2.
So 2 is the remainder.
Yeah.
Okay, so remainder of 2.
Okay.
So if I go 44 spots to the right of this repetitious decimal, what's the second digit after the 6th repetition going to be?
9.
Yeah, exactly.
Mm-hmm.
In other words, that would be repeated once, twice, 6 times, and then I would have to go 2 more spots to find that digit right there.
Yeah.
Okay? All right. Okay, another number property question. What is the greatest integer that will always evenly divide the sum of 3 consecutive even integers? And here are our possible answers. And I list these because it can be useful. Now, the question is, what is the greatest integer that will always evenly divide the sum of, well, do you know what 3 consecutive even integers means?
Yeah, it's like 2, 4, 8.
2, 4,
No, 4, 6.
2, 4, 6, or 4, 6, 8, or 12, 14, 16, things like that.
Yeah.
Okay, so we're looking that will always evenly divide the sum of 3 consecutive integers. I would take the 3 smallest and add them together.
Mm-hmm.
What do you get?
12.
Okay, so what is the greatest integer that will always divide into that of these answers?
The 6?
Always test the largest one because they're asking about the greatest one.
Okay.
Does 12 divide into 12 evenly? When I say evenly, I don't mean that it produces an even number. I mean there's no remainder.
Yes.
Does 6?
Yeah.
Does 4?
Yes.
Does 3?
No.
Yep.
Yeah.
3 divides into 12 4 times.
3. Yeah.
And 2 divides into 12 6 times.
So all of them.
So, well, that's the greatest one, though.
Okay.
In other words, I screwed up here. Let's take the next 3 integers. We took 2, 4, and 6. But if you take 4, 6, and 8, that gives you a total of 18.
Okay.
That is not divisible by 12.
Yeah.
Nor is it divisible by 4.
Mm-hmm.
So 12 is not our answer.
Okay.
This is a bit tricky of a question.
So it has to be like for all the even number, or is it like I try only 3 numbers even?
Well, notice that the first 3 numbers we came up with were 2, 4, 6, and they added to 12. The next three you could possibly come up with are 4, 6, 8, which adds to 18. The next one would be 6, 8, 10, which adds to 24.
Yeah.
The next one would be 8, 10, 12, which adds to 30. So notice the pattern. There's a separation of 6 between each of these numbers.
Yeah.
12 does not divide into all of them.
Yes.
6 does.
Yeah.
So no matter which 3 consecutive integers you give me, it's always going to be a multiple of 6.
Okay.
This is 2 times 6. This is 3 times 6. This is 4 times 6. And this is 5 times 6. So we know that no matter which 3 consecutive integers you pick, it's a multiple of 6, which means 6 is going to be the largest number that divides into all of them. Every time. And it doesn't have to be divisible by 4. That's not the question. The question was the greatest number.
Yes.
Well, 12 doesn't divide into all of them. 12 doesn't divide into 18 or 30.
Yeah.
But the next biggest number that we test is 6, and it does divide. No matter what 3 integers I pick, they're always going to be a multiple of 6.
Yeah.
All right. Let me move on. Averages. What's the average between these 3 numbers? How do I find out the average number? Total them up, and you divide by the number of numbers that there are.
Okay.
Okay?
Yeah.
Okay.
Which is 5.
Which is 5. What's the average between 2 and 5?
5.
Add them up.
Oh, it's 5, 6, 8.
7.
5, 6, 7. Divided by 2.
3.5 is the average.
5. Okay.
Okay? So you always get the average by adding up the numbers and dividing by how many numbers. Pretty straightforward.
Yeah.
What's the average between A and C?
It's A plus C divided by 2.
Correct. Okay, so that's average problems. Now let me give you some more. If the average between, in other words, the average between A and minus 5 is 10, then what does A have to be? So let's put it into an equation.
15?
Correct. In other words, the way we would do this, we would add these 2 numbers, which is A minus 5 is adding them. Divide by 2, that has to equal 10.
Yeah.
And then we solve that equation.
Yes.
So A is equal, or A minus 5 is equal to 20.
Yes.
Which means A is equal to what?
15.
No, solve that. You have to add 5 to both sides.
Add 5 to both sides?
Uh-huh.
Which sides? It's only A.
Or hold on, let me write it down. Okay, I'm trying to isolate A, which means I got to get rid of this minus 5.
Okay,
so I add 5.
25, is it 25?
Exactly. A is equal to 25.
Yeah. Okay.
Okay.
And then we divide it by 2.
No, we solve for it. In other words, they told us the average. They told us the average was 10. But the question was solve for A.
Oh, okay.
Okay. So we did divide by 2, but in our original equation.
Okay.
Okay.
Yeah.
What is the average between these two numbers? And you need to come up with the answer as a fraction. In other words, they give you a multiple choice, and they're all fractions, no decimal.
Is it one?
Part of the problem with using a calculator is you're almost always going to get decimal answers.
Okay.
So if you're looking at a multiple choice test and you need a fractional answer, you either have to know how to convert that decimal answer to a fractional answer, which isn't that easy to do. So let's do this manually. Add these two together and divide by 2, and that will be your answer.
So if we add it, it's going to be 1.6.
No. How do we add fractions? You're not going to be able to do this on a calculator, because the calculator is going to give you a decimal answer.
Okay.
So we have to find a common denominator. What's the common denominator going to be? Between 2 and 4.
2. Is it 2?
It's 4. It always has to be at least the biggest number. Can you excuse me just a second? I'll be right back. Okay, sorry about that. My guy is here to turn off my sprinkler system. I had to let him in. Okay, Munira.
Yes.
So the common denominator, remember how I taught you to do it? Take the biggest number. First of all, see if everything divides into that. And in this case, it does.
Yeah.
So 4 is my least common denominator.
Yeah.
What goes here? How many fourths is 1/2? Divide 2 into 4 and then multiply it by 1. Okay. And then as soon as you do that, make sure that that is the same as that. If it's changed, you've done it wrong.
But it's not the same now.
It is the same. Okay. And then over here, that's just 1/4. So now I can add them. What's 2/4 plus 1/4? When you're adding fractions, as long as the denominator is the same, you can just add the numerator. Okay. Now I got to divide this by 2. Because there's two things, and I'm looking for the average. So I have to divide 3/4 by 2. What is 3/4 divided by 2?
And how we do that without a calculator? If I want to divide like fractions.
Let me show you how to do it without the calculator. We know how to divide a fraction by a fraction, right?
Mhm.
So let's make this a fraction. Let's put a 1 under it. Now divide 3/4 by 2 over 1. Remember, you flip the denominator and multiply. So this problem becomes 3/4 times 1 over 2, which is 3/8.
Okay.
That's the answer. Now, if you tried to do this completely from start on a calculator, you would get this number. And the question is, would you know that that is the same as 3/8?
Mm-hmm.
And I don't know if you would know that or not. So that's the reason. You know, I'm not sure that you're not going to need to go to this website right here. I'm just going to point it out to you as an excellent website to practice your math skills on. If I'm going to go over here and I'm going to copy and paste that into the chat window of GoToMeeting. I want you to click on it. Do you see over in the chat window of the GoToMeeting screen?
Yeah.
Click on that link you see there.
It's done right now. Can you put it again?
The whole panel is gone?
No. I have GoToMeeting right now, but the link is not
The chat thing is not there?
there. Link.
Go down to where it says chat.
Yes. And then?
Do you
Okay.
see that link?
Yeah.
The www.aplusmath?
Uh-huh.
Click on that.
I do.
Okay? It'll open up this window you see.
Uh-huh.
Save it
Okay.
as a favorite. You know how to do that?
Yeah.
Okay? Save it so you can get back to it.
Okay.
This is an excellent app for practicing adding, subtracting, multiplying, and dividing both positive and negative numbers.
Uh-huh.
And it's the best one I have ever found.
Okay.
You don't need to do the 2x1s, but do the 1x1s and both multiplication. Check those off. Let me show you how it works. I'm going to start it. And you don't have to worry about speed. Just be able to do all of these. What is 6 plus a negative 7? And I'll put the answer in. But when you're doing it on your own, you'll want to put the answer in. Okay? When you're adding a positive number and a negative number, what do you do? You can do this on a calculator.
You know, yeah.
But I would strongly suggest you be able to do this without a calculator. Single digit. Addition, multiplication. I just fear that you're going to have a terrible time with this test if you don't master single digit addition, subtraction, multiplication, and division.
Yeah.
Okay? This is minus 1. The way we get it is we subtract 7 minus 6. We come up with 1, and then we put the sign of the biggest number. Well, the 7 has a negative sign, so I'm going to put a negative 1 there.
Okay.
Okay? Now, what is minus 5 divided into minus 5? That's a division sign. And that would be 1. It tells me I got the right answer. What's minus 2 divided into 22? Well, that's minus 11.
Yeah.
Right answer again. If I put in the wrong answer, if I say 11 goes into minus 88 8 times instead of negative 8, it'll tell me, sorry, the correct answer is negative 8. So if you get it wrong, it will correct you up top. But I would suggest you spend 5 or 10 minutes every day on this.
Okay.
And it will help these are called flashcards, basically, and then it's just a drill to get your math skills better. Okay, in this case, I got -4 minus a -9. Well, I'm going to turn that minus into a plus, turn that into a plus, turn it into an addition problem. And now I have -4 plus 9, which is a +5.
Yeah.
So I would like you to practice on this as much as you can.
Okay.
In terms of stuff you can do on your own when we're not in session. You're welcome, John. See you next spring. In terms of practicing on your own, I would say this is the best thing you can do for a while.
Okay.
Till you get really good at this.
Yeah.
Okay, you got to get to where you can do all of these, all single digits. Now let me back up and hold on a second. Let's see. Let me click on that again. Notice that I only checkbox the 1 by 1, the 1 by 1, the multiplication, and the division. And that's what I'd like you to do. Don't worry about the 2 by 1s.
Okay.
Just practice on those 4. And you'll get good. I mean, once you get used to it and just practice it, you'll get real good. And you need to be able to do these in your head. You don't want, it's almost impossible to do higher math on a calculator. There's just too many single-digit operations that you have to do. When I solve an equation, I might have to do 6 or 7 single-digit operations, whether I'm adding, subtracting, multiplying, or dividing.
Yeah.
And I want to be able to do those quickly and accurately.
Yeah.
So I would work on that for sure. Now, let's talk about, since you're dealing directly with me, this is another website. Let me copy. This is my website, and this is like how I would like you to go ahead and click on that digital math tutor also.
Yeah.
And save it so you can get back to it.
Sure.
Okay? Now, if you go to that front page, to pay me, you need to click on that Buy Now. Okay? And it will allow you to open up a PayPal account if you don't have one. You can use a credit card or your bank to finance it. But this is the easiest way to pay.
Okay.
And what happens is when you click Buy Now, it opens up another page where you put in the price. Well, the only thing you owe me at this point is $32. So you'd put in 32, and then you'd put in your own PayPal information, which I can't see. I don't get to look at this. But it is the easiest way to pay by far. And so my policy is that I require you to pay for a session before we do another session.
Sure.
Okay?
Yeah.
So if you can pay $32, then we can do another session whenever you want.
Sure.
Okay?
I'll do it. Yeah.
Okay. And you can also, on that same website, schedule session. Let me show you a little bit briefly how to do that. If I go back to that and I scroll down, you'll notice the Buy Now is there. Well, the Book Now is over here. If I click Book Now, it'll let you schedule. You'll want a 1-hour session. Click on that middle thing.
Yeah.
And then it'll show you my complete availability for whatever day you want.
Okay.
And hold on just a second. There it comes. Okay? In other words, for today, you could have any of these times. But only those. And if you wanted something tomorrow, I click on Friday, and it's going to show you, okay, more availability.
Okay.
And if you click on one of those times, it'll let you sign up for a session. You don't need to talk to me. It's fully automatic. I get a text message saying, Manira has signed up for a session Friday at 10 a.m. Okay? So you can both pay and schedule on this site, digitalmathtutor.com.
Yeah. That's good. But I cannot pay like directly by my Visa, right? I have to use a
You have to use PayPal. Yeah.
Okay.
In other words, you'll have to open a PayPal account.
Yeah.
And they'll let you fund it with a Visa. So you can use Visa, but what it does is it funds the PayPal account, and then you pay using the PayPal the way I just suggested.
Okay.
If you have any difficulties, you can always call me. My phone number is the same one on this, whoops, wrong page, but my phone number is listed right at the top here. Right there.
Yeah.
Okay?
Yeah.
So if you have any questions or problems, you can always call me, text me, email me, whatever you like. But on this single page here, you can do anything in terms of scheduling and paying for tutoring. All right?
Yeah. And there's one thing. How can I view like the sessions that we just did right now?
If you give me your email address, I will send you the link to this after it processes.
Okay.
In other words, it takes my computer a while to process this into a file that you can see.